Hello again. So last we've finished. We've end on the code architecture. So let's continue this. Mhm. Okay, you can see my screen now. Okay, so let's look at this ugly paint drawing. So last we concluded that we need to some kind of controller with facade to device, which would be a meter and the receiver, and the main thread or module or anything that would just control all of it. Okay, now we know that we would like to rename this surely, because this main function would be a controller. Okay, what can I say in the software development is that the names of classes, modules, functionalities, variables, anything is one of the most important thing today. I mean, during times that we have frameworks for everything, actually, one of and that design patterns are kind of soft skill, let's say, most desired on the market. I think that coding itself, writing a code, isn't that crucial anymore. I mean, writing a code is the simplest job in programming and software development. And I mean it. Writing a code for given functionality is the simplest thing you can think of while coding. The more important issues are naming things, making a design, because code can be written to do something, but what's most important is that you will need eventually to change or modify it or read it, understand how it works. And when modifying it, we can get in all sorts of troubles that we can imagine if it's written bad. Okay, I'll make sure it's recording indeed. Yeah. Okay, coming back to this. So this would be our controller now. And we probably will come up with another tasks for this class. And what we called controller previously. Let me do this. Okay, what it's doing is it steers the emitting and listening of the sounds or signals and saving it. So make single measurement is its use case. So I think it's the best description of it would be that the class, the module that makes a measurement, makes an experiment. And experiment, it's not research project, it's just a working machine. So measurer is a good description of it. Oh, let's ask Ayaya. How do you think I should call the measurer class. Or agent responsible for conducting measures. Let's not overthink it. Oh my gosh. Sampler. I don't like this at all. Let's call a sampler. Let's choose a sampler. I'm going to move it to the draw.io eventually, so don't worry. Okay, processor. And as we said, we would like to be able to replace the emitter and receiver. So we can think of it as the concrete class. And we could, oh my, we could use the design pattern of abstract factory. Is it any tag? Yeah. Okay. I don't want to draw it here. Let's just signalize that it needs an abstract class. It's getting really messy. So, one thing I need to tell here is when we have different, modes, different environments to measure, physical environments to measure the signals, we can't do emitting a sound and receiving some, for example, near infrared signals, because it's not compatible. The emitter and receiver must operate on the same medium, physical medium. So I think that, and also when we think of processing the results, we would also need it to correspond to the physical medium, and that's why the abstract factory would be very relevant here. So the processor is the one that gets the data from the sampler, and it also needs to be a concrete class here. So the processor, the method for processing our data would be associated with the kind of measurement we take. So this will be abstract. And these classes would be associated in some concrete package. So there will be a factory. Okay, and like, what do we need to compute it based on the result, the representation, the result, the processor, the history. The history would also, yeah. So what's stored in history would be the type of data. No. The type of data that's received from the receiver class. Yeah, so sampler and sample. Let's say sample for a moment. And okay, and it also would be a concrete class in this case. And we would need to make it an abstraction. So this would also need abstraction. And the factory class would also need abstraction. So we could define its interface. Oh, and this abstraction would contain the four class, I think. Yeah. So the emitter, the receiver, the sampler, and the processor of data. So all of this would be part of our factory, and now it's really time to move it to some proper software. I didn't have an idea that it would be so messy in the paint. Okay, what's problem for me is that the sample class and sampler class are called very similarly. It can be this way. So let's ask AI again. Okay, so I have a sampler and a sample classes. The names are too close, similar. Can you suggest some improvement? Result is taken. So again, no good propositions. And the recorder, no. So sample I think is a good. I mean, what would contain the sample? Oh, I'll ask. What would be the content of a sample class given it is an data aggregate class? Float, string, datetime. Why did I ask it? Because I'm going to figure out if the sample is a good name for this. And as we see that, oh, and it's also called, it's frozen. So what we got here, the sample class contains some immutable data, and it even gives some methods to manipulate it to other formats. So I think this is a perfect name for this class because it's exactly what I wanted to. This name to indicate it's exactly this functionality the name of the class indicates. So now I know that I would need to rename the sampler class. So let's rename the sampler class. It makes a measurement, emitting and receiving a signal. Yeah, transceiver, very. Oh wow, look, it got the idea what I'm playing. I don't like the this transceiver because it indicates that this combines the two, that it combines the methods of two classes, but it doesn't. So this class should be responsible on higher level of code. It dictates. It is some kind of controller, manager, but use single word. I don't like it. Maybe let's stick to the measurer. So I'm not happy with what the IIR responded. Okay, what's more? What did you say? Wow. Nice. Okay, never mind. Okay, I got some thoughts about the representation because I think it should use. Will it be good to show it in the window app or just the console app would be enough? I think it would be good to show some plots in real time. But actually, it wouldn't be really necessary to have a user interface. So now let's. So how does it affect our architecture? So we don't know if we need some window app and user interface, but let's keep in mind that we would need some. So the controller would be the main class, which would orchestrate all of it. So the emitter and receiver would be ones that would need work in parallel. So probably we would need some threading. Yeah. It would need to repeat the measurements all the time. So it would probably work in loop. And the loop will be part of an app, a window app. So if we introduce the window app, the main thread would be in this class associated with the window, and the controller would be. So I think the controller would be this, that the main class that would create a window and something else. So it is a good thing to set this class as the main entry point to our software entity. Yeah, what I haven't learned from anyone else, but have learned from my own experience, is that some kind of entry point to application is a very good practice. So it's whether we are talking about testing making some tests, the integration test or understanding the architecture, it's very good to have some point in the software of the control flow that we can pin the beginning of the application to. So usually when we are talking about microservices, it's a little bit messy. That's some other case, because in microservices we have multiple functionalities, but I always struggled to test it because it was not clear what modules or functionalities are called in what sequence. So integration testing of microservices is a pain because we need to draw a whole pipeline of data and track what's going on. So I think the entry point of even of a microservice, defining a highlighted module or functionalities that indicates where the incoming signal to start the app start it up or do some functionality comes from. Okay, so much talking for now. So how it would like from the point of view of the sequence diagram. Oh, I forgot how you call it. In UML, how the diagram of sequence of actions is called. Okay, from the point of view of sequence diagram, how it would work. So the controller, the entry point is that the controller starts the app. It's called to start the app. It's creating. Oh yeah, what will happen? It's calling. It has the factory, concrete factory set. So we need to give the controller the concrete factory. I need to write it down. So the controller would need dependency injection. And now the factory creates the emitter, the receiver, and the processor. Yeah. The controller creates the history box and the measurer. Okay, so controller is responsible for measurer, history, and the factory itself. It would use it, but as a dependency injection. On the class diagram, it would be indicated differently by when we're talking about the UML. Probably not very clear. So this would be an aggregation, and that would be the, oh my gosh, how it's called? Sorry, I'm a little bit rusty on it. You know what I mean. So one of the when class is connected to the other by the aggregation relation, it means that it's responsible for creating it, and with it's this empty arrowhead, it means that it contains it in a way that it's associated to it. It's a governor for this subclass. Not subclass, the sub entity, but it's not. It's given from outside. It's not responsible for creating it. It's not strictly aggregated in it. How do you call the types of class relations in class diagram? In UML class diagram, aggregation and composition. Yeah. Aggregation and composition. So you see, this stream would be, wait a moment, aggregation, hollow diamond, composition, this diamond. Okay, it's a little bit tricky because I could switch this. What are the two meanings of it? Aggregation, the parent has a child, but the child can belong to others or exist on its own. Okay, composition. So I've misplaced these two ideas. Sorry about that. As you can see, this stream would be not very much into coding itself, but it starts to be a little bit educational. Let's see how it will go on. I don't have a strict plan for it. I mean, I do have a plan now that it would be split into some parts because the first stream from yesterday ended up with me being a little bit tired. So anyway, if it's split into some sections, I think that we could leave it as it is. So this would be the part 2 of this coding challenge. And we are focusing in this video, we are focusing on the code design and the system architecture. And yeah. And maybe it's good time to tell what's the difference between design and architecture, because design of code is more connected, more associated with the design patterns, the software itself, the organization of classes, modules, and something within a single service, single package, or single microservice, or anything. And the architecture is something we are using to describe more of a system. So why am I on the first place using the word architecture? It is because we have some devices here. So this would not be an independent being like one HTTP agent or something like this. It will definitely use the outside devices, so the microphone and the speaker. And ideally, I dream about having this delegated to some other independent, maybe microservice, maybe Docker, something connected by HTTP, which would be possible to connect by my house Wi-Fi. That would be something very exciting. So the architecture is a little bit higher level than the code design. So let's say that all of this, maybe even here and here, and here would be the core component of our system, and the emitter couple, the receiver couple or sub or unit would be something else, and the representer or some other agent or entity that utilizes the data from the processor would be eventually, probably can be the other physical unit even. Yeah. So we see that there is some strict connections between the units. And what is very important in this topic is a question of isolation. Oh, it's hard to overstate the importance of isolation as part of building the biggest system. At my work at IT previously, this was the biggest issue at my teams. So you see, sometimes companies are trying to estimate its. Oh, sorry, I didn't share the screen with you. Okay, so again, the emitter entity, the receiver entity, the core unit, and the result presenter or some other entity that utilizes the results from the processor. So what we see here, okay, what we see here that, oh, and some entry point, but it's least important at the moment. I mean, it is indeed important because it's like the switch on the personal computer, the on button. This is the one button that starts our application or is an entry point to what we are going to use it for. And I think it's also hard to overstate the importance of it. So okay, a little bit speaking now. So what I've encountered in as a Python developer is that in many systems the isolation was laying flat. I mean, I'm probably using it in the wrong way. I mean, there was no isolation at all. A little bit of philosophical. Let's get philosophical for now. So, why the microservices stood out, and the idea of microservices emerged, and in the first place. So, I'm sure that it's just the matter of the isolation, because when deploying a microservice, you are forced to isolate it and give it a single entry port through HTTP or maybe some other protocols. In case of, for example, electronic hardware, never mind. So you need to force developers to apply some good practices. And what's my greatest finding in the IT industry is that, and let's state it, what's my greatest find from the IT industry is that no matter how good practices you apply, no matter how good frameworks or methods to work you use, anything can be messed up, everything can be broken if there's a will to do so. So it will always be a way to misuse even the best systems. And I'm seeing a race among the IT specialists, I mean IT trendsetters, to make some IT teams error proof. I mean, make them not prone to bad practices. And it's an impossible task. I mean, if you get the wrong attitude, if you get the wrong people, everything can be broken, everything can be messed up. And it's done. It's being done, I mean. So we are seeing the microservices that would be a remedy, that was thought to be a remedy for the spaghetti code, for some mess projects, and they were being started to be misused by developers. And if you put more than 6 functionalities in microservice, if you give it over 50 classes, it won't work as intended. It will be a great mess again, and you would try to search for new concepts of teamwork. You would say the Scrum doesn't work. You would say the Agile doesn't work. You would search for some new innovations in project management, and it would fail again. Because no matter how good your approach is to organize the work environment, it can be messed up if there's wrong attitude for it. Yeah, and it cannot be overstated. So why? Because people don't stick to the isolation rule. I'm not sure if isolation is a word in the solid principles. So single responsibility, open clause, lift cost substitution, interface segregation, dependency inversion. What was about? What was about it? What was it about? High-level modules should not depend on low-level modules, but should depend on interfaces. Okay. No client should be forced to depend on methods it does not use. Replace it for objects subclasses without breaking the application. Yeah, so this is the substitution rule we are using by creating abstraction here. The single responsibilities say obvious. Yeah, okay. What about isolation? Oh, it was called encapsulation. Can you? No, you can't see my screen, of course. So yeah, I'm reading about the solid principle. And what about isolation? So A sit in databases, the rest in HTTP, APIs, process resource. Okay, so operating systems. Fault it doesn't it's not about it. I'm curious if it will mention the encapsulation term. How do you call isolation in class in software code classes design? Yeah, encapsulation. Good. Yeah. So this is about the having fun. Can you see my screen? Yeah, good. So yeah, this is it. So in case of sequence diagrams, let's make it in our minds. So okay. The controller is responsible for measurer history. It aggregates the factory. So controller composes of measurer, history, and it aggregates the factory. The factory composes of the emitter, the receiver, the processor, and it uses the sample class. The sample class is a part of history as a composition relation. Okay, what's then? So the controller, after initializing, it would check if okay, so emitter and receiver needs a method to check its correct working, because it's not it's abstract class. We need to introduce a method to let's say just check to see if it's connected with the device. So the controller runs all of this stuff, let's say up to this point, and then it enters a loop. It can enter the loop such that it every 100 milliseconds it sends the command to the measurer. I think the measurer could be the owner of the history, because controller actually does not need to. Oh no, it needs to access the history for the processor. Okay, maybe we'll consult it with the AI, but not now, because I have an idea. I would like to discuss with the AI the SONAR design, the SONAR software design, and I'm very curious if it would come up with the same diagram, because actually I think I could do it well, and I wouldn't be forced to ask her for it, and maybe even I don't trust it. I don't trust the AI so much that I would let her do my code design. Actually, it was being quite fast. We have now less than an hour, and from previous part of the recording, it was, I don't know, maybe half an hour. So we've done this idea diagram within an hour, because today gotten into some philosophical findings. Okay, what was my point of view? Aha. Where would the history go? The processor uses it, the measurer uses it. But it's only a container. It's not very important to be this as a part of. I was thinking maybe if the history class would be responsible to push the samples into the processor queue, but it's a bad idea. Let's leave history because again, what's about this name? The name history suggests that it's written in stone and does not take any action. Because, for example, a history like in human history or in a book does not take any action. It's written and it cannot be responsible for taking some action because it's in the past, of course. So let's not overload the history class with functionalities. Let's be it a container. Okay, so the processor would use it, the measurer would use it, the controller would create it. So just as I written it down here, don't worry, I'll be transferring it into the draw IO. The tool I've used a lot for my UML diagrams. Maybe one more thing about the diagrams in UML. It used to there used to be a desire in the 90s. I don't remember these times, of course. I'm much younger than this. Just kidding. There used to be a desire to program to do high-level programming by drawing UML diagrams, and then the coding would be done by itself. And this felt flat. I mean, it was a huge disappointment at the time. I'm sure sorry for my English, probably. I'm convinced that it would happen again. So probably some people would be tempted to make some diagrams, high-level diagrams, and use AI large language models to create the code based on it. Given my knowledge about the intelligent algorithm, this could work for some repeatable work. So, for example, CRUD microservices. Because it utilizes the knowledge of existing systems. And this indeed could give some viable results. But in case of engineering, I mean, as I understand engineering as crafting new entities with known rules or elements, the building blocks, The AI models can't do this, are very poor at it, mainly because they're trained with the back propagation error algorithm, which is founded strongly, I mean, entirely in mathematical, the calculus, the part of mathematics. And yeah, I think it won't work this way. We need to, as an industry, we need to make another big leap, big step forward to let the AI be a part of it. Software engineering thing. Never mind. I really forgot what I was talking about. The sample, the history would be here. Okay. I know. So there was a temptation that UML diagrams could be the source code of the IT systems, and it was a failure. Mainly because actually I don't know the details, but what I know from my experience now, that UML design isn't written in stone. It will change. It will be changed. It will be modified, and nobody would care about modifying the diagram itself. My point is, the UML diagrams are kind of useful in designing the functionalities, the system details, but they're also only a clue. They're only some kind of roadmap, and it will be outdated quickly. And there's nothing to worry about. UML diagrams are meant to give general knowledge about the system, to give you a clue what's connected with what, and I'm totally against updating UML diagrams when updating the system. You don't need to do it. I think it's a waste of time, and it makes total confusion. That's why, for example, developers don't like commenting code, because when you edit one thing, it should be edited only in this one place. If you forget about updating documentation, there will be a dissonance. There will be a it would diverge. One documentation would diverge from code, and for example, comments would diverge from what code does. And there's nothing worse. No comments in code are better than misleading comments. So you get the point. I mean that divergence between what system actually does and the documentation is inevitable, and probably it would lead to very serious problems. So let's remember that UML diagrams are only a clue. Don't make them too detailed. Ideally, put in the UML diagram a note that it's a initial design. And that's it. I think I have draw.io in my installed locally. Yeah. Sorry again, I didn't want to show history. New version, new diagram. Save as the stream folder. Mm-hmm. Can I close the file without closing the output? Yeah. Yeah, that's good. So what we got? Okay, it's just I've just created new file. Uh, like you see, the class diagram here. That's it. How do you make wider canvas? Oh, okay, just sliding. Maybe it wasn't a good idea to get these initial ones because it disturbs me. I will put them aside. It's not what I really wanted. Unfortunately, I didn't connect my other display. I have an idea. I will make a photo on my phone. And I'll use it here. That is exactly why I like paper. And I can rotate the paper without selecting options. But on the phone, when I'm rotating the image, I need to do it with other options. Okay. And before it, let me leave for a quick break. Okay, I'm back. So let's get started. So the first class would be a controller. Oh, you know. Is there some more elaborate class? It was. Probably what's this? This is this. Yeah? Yeah. Oh, the interface. This would be useful. Okay, so the controller. Uh, inter 6 interfaces. 6 for the factory. Let's call it the abstract factory. Don't know why isn't it in italic. Probably I'm using the wrong type of. Never mind. Abstract sample. Yeah. Abstract processor. Abstract meter. Abstract receiver. And what? Processor. Oh, there is some. It's too much, 6 of them. So the factory, the processor, emitter, receiver, sample. 5. Never mind. Okay. The measurer and the history. Of course, the history would have the history itself. Bucket. No, bucket. It's not ordered because our history is a sequence. Why does it say type here? No idea. Ah, okay. It's just a placeholder. Oh, that's not very friendly. Wow. Mhm. So method would be initiate or just init, of course, and loop. Okay. So this is the field name and the type, just a list. Simply list. Mm. As I said, the names of variables are the most important thing as a programmer, as a programming part of the job of the programmer, and it's very underrated. Let's call it just history. I don't like when the field of the class repeats the name of the class, but let's leave it now. Probably nothing. Where's the sample? The history. Yeah, so the sample would be an abstract. I mean, the sample is not unified across the different mediums. It must be concrete, so we can assume that the receiver returns the sample as is. So the measurer does not need to make any assumptions about it, any casting or anything. So it's the type of sample. Emit beep would be uh, argumentless. It does not need to specify in this case. In this case, we assume that there is only one type of signal for for one concrete emitter that we want to use. And if we would like to use another type of signal, we would make another concrete emitter with different functionality. Yeah, actually, the another concrete factory. What? That's what we like, fun, isn't it? My gosh. My, why can't I? Man, this is crazy, isn't it? It's a different type of diamond. I'm indeed a little bit rusty in it. It used to be faster for me. Yeah, I find it a little bit not very satisfying. No, something's definitely wrong. It didn't used to be like this. Oh, never mind. Okay. Okay, controller responsible. Actually, let's make it this way. Or actually, let's put up all the abstractions at the top. Okay, so factory creates processor, emitter, receiver. Not samples, not samples are created by the receiver. Okay. I wanted to connect these abstract classes to the concrete one, but it would mess up a little bit. So, the results. As we've seen here, the result should have uh, some metrics, uh, especially distance. Let's say the value and metadata in form of dict. emit data envelope. This would be useful here with the communication of the device. So it would be created by the it would be defined by the facade, but this would be the responsibility of the abstract client. So I don't need to include it in my general design. Measurer is strictly behavioral class. It probably doesn't need any fields. Oh, definitely. So measure is created. It's it checks if everything is okay. Then it conducts the single measurement. So which consists of emitting and getting response, which can be private methods. What else? Save sample. Saving sample could be also a part of get response method. This could be changed. It's only a draft, as we say, as we said. So the measurer would be responsible to it would use the history, so it would maybe it would need to store a pointer to it. This photo thing was a bad idea. Okay, so what's the measurement use case? Mm, it will give a command to conduct single measurement in which it would call the emitter to emit beep, get response. It's getting the response. It's saving sample to history, and its job is done. So that's all for the measurer, I think. Okay. Yes. Factory, history, measurer. How about the processor? It isn't included. Measure, process. Some kind of getter. And the sample. Where do we? The result. Okay. Okay, I think we don't need to specify methods in the concrete because the processor would be responsible to process the samples, and it would know how to do it because it would be a subclass of this of this abstract processor. Okay. Where's the result? Here. Some kind of representation. we could utilize different such methods. Let's write it this way. This could be all we need. Okay. And as you can see, there is a problem from the design point of view, because result is not handled. Actually, we can tell that it's not handled by the controller, which should take care of it, because it receives it from the processor, and we'll get to it. And we want to give him here an agent, I mean the device. Oh, and one more thing, we could put an actor here that starts the controller. Actually, it's not necessary, but why not? Yeah, just use. And the device, IO device. Do we have something like this? No, it's for the sequence diagram, I think. We can just use the object. Where was it? The component. Okay. Actually, I could imagine that the actor, the user of the module, is responsible for creation uh, of the factory. Okay, these abstract classes, I'm not going to connect them to these to concrete classes. Why does the history create the processor? Oh, it's created by the factory. So, okay. Looks good. This factory creating methods. I mean, creating arrows mm, introduces a lot of a little bit of chaos here. Okay, so the measure class is, I think, very well defined. Mhm. Let's talk about the factory. Why the factories is responsible to create history? Is it an error? Yeah, this was probably the surplus arrow. Can you hear me? Yeah. Hmm. Okay. Uh, so now the use case, we would need to think about the use case of processing the samples. Oh yeah, so that was the probably the one to use as the class block, because it has built-in lines to divide into parts. So what? Okay, so measurer is not a class. This could be with variants. So it will have hard. It had. It will have the calling methods hard coded. So the emitter class needs to have proper interface beforehand. And yeah, and it needs to be public. Just this. But the receiver could be a little bit more sophisticated, I think. So listen would get response. Yeah. So listen would listen command, as its name suggests, would suggest that it would start some listening to on some port for some incoming messages, but we just want to, on this command, we want to start recording for some time, and then just return the recording itself. So the emit beep and get response would probably be delegated to another thread. I'll be thinking about some semaphores later, probably. So just a single function, single method to receive the signal. And that's it, I think. Okay. So, what do we want to do with the results? We need to present them in some way. As I as I stated here, the result would be represented by some other module or class, and we would like it to be interchangeable. I mean, we surely do not want to the controller to include the the use case. I mean the code for presenting the values, for example, whether it would be in a form of user interface in a window app or just printing it in the console. So I want it to be the separate class, and of course I want it to be abstract. Oh, observer pattern. I haven't thought about this. Let me keep in mind. That would be some good idea. But let's focus on the name now. Printer? Something more like UX. I mean UI. That's better. Viewer, display, or view. Mm-hmm. No, measure would surely return something. So single measurement returns sample, process sample gives us result, and print result would give us the effect. What's going on? Mm-hmm. And I think that could be all. And also the actor. In this case, actor would be. How do I we remove this? Did it work? I hope. I hope. The actor will be responsible for creating the display in form of some applet or anything. And that would be some elegant way because it would be handled by the script way because it would be handled by the script that would run the whole, let's call it, system. I think I have a very clear idea of what's my plan here. The display, print. Anything. This actually, it's, maybe it shouldn't be here, but for the sake of I don't know what, let's include this information with limited relevantness. And I think that would be it. I'm eager to connect these abstract classes to the concrete classes. I don't like my canvas to be limited. I like to have it very wide. Maybe I'll use some colorful arrows.
That's it. So the implementation of the interface. Maybe let's call it implement. Give it fancy color. I would like it to be some ghosty line that's quite faint but visible. Gray would be better. I'd like this. Anyway, let's try with pink. Better, very much better. So I think green line would look like more like it's permanent, and this pink hue gives me the impression that it's not very permanent arrow. I like that this arrow has a big head. Probably I'll think about changing it in the other processor. Is here. The emitter is here. And the receiver here. And this is what? Sample. Very, very far away.
I've seen some equidistancy. Oh, like this. Maybe some of the programmers will remember playing with real cables while programming. I mean the wires which you need to ideally put into this wiązka, groups of wires. Nice. Bundle. Probably more like beam. Okay, I think it's looking good. And I want you to know it's not the art for the art. I'm sure I will be using this plot, this diagram while programming. So I want it to be actually readable. And let me take a quick glance at the paint diagram from previous. Did I forget about anything? Okay, so the emitter receiver have abstract classes. They have facades to the device. Received data is a time series of sound intensity. Okay. Did I included this in the sample? So the intensity would be a part of a result after the processing of the sample. So the sound intensity surely won't be here. It could be here, but I'm not willing to move it. Okay, so I think this is okay. How about some calibration? Oh, never mind. Emit data envelope. So the package that needs to be sent to the the emitter device, the speakers. It would contain the situation, pitch, sound definition. As we said, this would be included in the receiver concrete concrete emitter at the moment. So this is served. The result, okay. The representation, okay. Sampler, abstract class, measurer, make single measure. This is the part of the loop. History processor factory. And now, what about controller wouldn't be able to accomplish the whole measurement within the time interval of the loop? I think it wouldn't be a problem. Maybe let's focus on sequential measurements. So loop would try to make one measurement, then sleep or delay for some time, and then do the other one. It's actually uh, not necessary at all to have it being done in regular intervals. Actually, single measurement is much more important use case. So if we would be if we would like to compare consecutive measurements, let's think about it later. Comparing consecutive measurements. Okay. What next? The factory is done. Processor results. So the emitter, the windows of the receiver. How about these waves? Yeah, I think it's fine. So this is it for paint. Let it be. Let it live in the Hall of Glory, Hall of Fame, somewhere, and let's focus on this for now. Okay. Doesn't it conclude the part of designing the observer pattern? Ayaya wanted me to include the observer pattern in the sample, I think. I would like to see how to connect your measurer to a result printer by observer design. A measurer here and display here. So now the controller is doing the measurements now because it needs a processor in the way. So it cannot be done directly. It's some kind of pipeline. We could use a pipeline for the pipeline with some queue, some buffer to process consecutive measurements. Let's keep in mind that I know that such possibility exists. I'm happy with what's done here. I won't be separating the pipeline into separate being. The controller will take care of it for now. Yeah, cool. Did I want to add some prompt? What was my question? Something like UI, yeah. But it's good. Something where it mentioned the sonar. Yeah, here. Let's enable sampler class makes the measurement emitting the signal. Maybe I wasn't the only one who got an idea to make a homemade sonar. Okay. So what I wanted to do now is surely add this to the repository. Oh, and rename it. Should I add it to the repository? Yeah, I probably could. Ideally, it would lie on some intranet page or some project wiki, but we don't have one. I mean, we do have README file, but let's just put it into the repository because the repository itself would be the only source of all the data for someone who would browse my this project on the GitHub. So yeah, let's put it in our repository. I would like to put it here also as a sake of for the sake of redundancy because I've spent quite a time on this. I don't want to be lost. So let's create docs here, but I want to include the date on it. Can I make a frame? Good. Uh, what was that? Never mind. Okay, so now last one thing on this part, which lasts over 2 hours. I would like the AI, our LLM, to come up with this design by itself. I mean, I would like to see it if it can if it can do it. Okay, AI, dear bot. Maybe let's not dear you. Let's not categorize her. Okay, dear you. Do you know what I'm planning to build? That's right. Uh, I'll ask if it can do it, but I don't want it to print it. If I'm in a moment, I wanted to give me the answer if it is able to show me some design. Tell me only if you would be able to do it for me. Do not do it yet. Just let's consider the possibility.
Nice. The hardware layer. Okay, never mind. Signal logic, yeah, do we know this? UI visualization, view, TK inter, Git workflow, we got it. Would you like to start by defining signal hardware interface for a specific sensor? Like, man, what's this? Ultrasound. Sounds good, but no. A hardware interface, writing code to control GPIO pins, serial ports. Yeah, good. Okay, but I have only my laptop at home. That's not a problem. Yeah, actually, it is a problem. Virtual sensor. Okay, fake signal. No, no, no. I want it. Please do not write any code or solutions yet until I ask. Uh, only discussing solution. Okay, but I don't want to simulate. I want to have working sonar at home using my laptop. Is it possible? Let's see what it will come up. Yeah, speakers and microphone. Good. Okay, I know I've discussed this design with her, so uh, let's start with the other tab. Yeah, this is a clean tab. This would be a good prompt to save. So let's call it do not act yet. Oh my god, not you. Sorry. Good. I want to build sonar. Make sonar on my laptop at home. No simulation. I want it to work. Using only your laptop's integrated hardware, speakers, and microphone is possible by treating the audio system as a transceiver. And because standard laptop speakers cannot effectively produce ultrasonic frequencies, never mind. It will work with audible range for typically. Oh, no. Pulse generation, emit a short high frequency ping or LFM. Whoa, it does know the drill. Linear frequency modulation. Did you study physics? Just kidding. Synchronized recording. The microphone must start recording exactly when the speaker starts playing. I don't agree. I would start recording before. In Windows version very low latency idle libraries like PyAudio are standard for this. It doesn't need it. We can record the signal beforehand, or if it would, maybe it wouldn't be a thread safe. We'll see then. Never mind for now. Signal processing. To see the echo in noise data, we'll use the matched filter. This involves cross-correlating the recorded signal with the original transmitted chirp, distance calculation, and speed of sound in the air. Isn't it too high? Never mind. Minimum range line. So if your ping is 10 milliseconds, the object closer than 1.7 meters. That would be problem. Implementing strategy. For Python 3 on Windows, you'll need NumPy, SciPy, PyAudio. Yeah, generates 5 chirp, plays and records some intensely, apply match filter, find the highest peak. For more details of pulse compression and sonar, you can refer to this Texas Instruments technical guide on instruments chip sonar. Would you like to discuss the signal processing mathematics? No, signal processing will be easy for me. We'll discuss the code architecture. Sorry if you are not expecting to hear some me playing with this chatbot. As I said earlier, there will be in the description of the stream of the video on YouTube, I will include the chapters, the timestamps. You could probably, if you would need to go to chapters, you won't be listening to what I'm saying now. So let's leave it. Okay, so propose the classes and modules be, oh my god, skromny. What? I thought I've known another word for it. Generator, transceiver, and processor. Full duplex. I'm not going to use it. I do have some experience playing sounds actually in some simple, or maybe not. Yeah, this was simple. In some simple video games. I've used the Allegro library for C++ and Pygame, and it was very easy. As I recall correctly, the Allegro played the MP3 or some other sounds. I've used the prepared MP3s. And when it was sent to play, it was like fire and forget. So it didn't need to be dealt with by the thread in my software. So yeah, there's no need to worry about getting two-way communication with the OT system. Definitely, we could use the microphone separately. Okay, how about the main script, module, or app? Which would you choose? Oh, wow. Instantiate the generated interfacing processor. What's the interface? What does it refer to? Audio interface, okay. So this would be our receiver emitter. So it would be our interface, audio interface. And the generator, I don't know what it's referring to. Okay, generating the waveform. No, it would be included in the emitter. So, okay, I see that it's treating the audio interface like this. SONAR processor, so the processor like here. And write a draft, I mean with some kind of pseudo code, high level of the SONAR API scripts. It's not a draft in pseudocode. Never mind. Nice. How does it correspond to this? Oh, let's talk about sample. ping generate chip row echo. So this would row echo would be our sample. Distance would be our result. And this print would be our display. And it doesn't include any history. It does have a processor. Now in here, the measurer would be, so no, it's not good because creating the, oh no, okay. So the audio interface does, okay, so the ping is a prepared signal, and it is, by the audio, it is emitted and the recording is returned. Okay, so this true while true loop is what we use in the controller. Nice, very nice. And how about the measurer? So it's totally omitted. Our measurer would be here integrated with this class. Nice, nice. So that would conclude our, or maybe one more thing. We can think about how to fit the comparing of many measurements, consecutive measurements. How can we fit this into this design? So the controller would initiate a loop by calling the measurement processing and printing of results, storing it into history, but it also has a power to do some pre-measures before loop. Before we enter the loop, we can, for example, measure some measure. Yeah, we don't even need to play a sound to use the emitter. We can, before the loop, we can get some samples from the receiver to calculate the background, for example, mean background or anything. This would be really helpful because the processor would need to subtract the background from the receiver. Actually, the receiver could do it by itself while initializing, and then it would treat a sample I mean something like calibration, yeah. So the receiver would use some calibration before returning from initiation from the constructor. Okay, but if we didn't do it, how can we apply it to the processor? So the processor is a part of this, and the processor is also the abstract. Yes, I think we could add the method calibrate to the abstract processor class. So why to the abstract? Because every concrete class would implement this because the controller isn't connected to the abstract factory here. So it wouldn't have the possibility um, to comply with the interface. The method called by the controller on processor must be included in the abstract processor interface, because otherwise it would raise an error if one wouldn't implement this method into a concrete processor. Yeah, so we have two options here. One, the receiver would calibrate. Two, the controller would do pre-loop calibration and affect the processor. I think this is, given that, let me state that this design is quite good, because I haven't thought about this calibration stuff beforehand, and now it turns out that it would work in this architecture. So I'm really happy with this design. I think it could be splitted in modules. It could be implemented on some microservices, and so on. So thank you very much for this 3 hour with me. And let's see you in the third part, when I would be doing some prototyping and coding with the IIA. So yeah, bye.